Hello, welcome to this video about the benefits of green in the city. My name is Marco Roos. I'm trained as a botanist from my biology study onwards. First, I've studied epiphytic ferns in the tropics, but I've changed to biodiversity in the city with a focus on soil and plant life as a basis for all biodiversity in the city. When we talk about biodiversity in the city, we are talking about the city as a complete ecosystem, comprising ecological patterns and processes in space and time. The ecosystem is dominated by anthropogenic activities and the urban infrastructure, like the roads, buildings, etc. The ecological patterns are determined by the size, the variation, the design and the connectivity of the different landscape elements in the city. The processes you can characterize by the amount of spontaneity, autonomy and the type of management or maintenance of the different landscape elements. The quality of the ecosystem is determined by the biodiversity present, and the level of biodiversity is related to the ecosystem services which are provided by the living organisms. The ecosystem services are represented on the right image. But I also wanted to stress the importance of high levels of biodiversity in the city, because if you have a low diversity, that means low species diversity, but also low genetic diversity. If so, you can easily lose one of the elements of an ecosystem, and that makes the ecosystem unstable, or it can even collapse if some species disappear. If the ecosystem is supported by high species diversity and these species have a high genetic diversity, then the overall ecosystem is much more stable. Here we see an example of the importance of urban plant life for the living conditions in the urban climate. The image on the left shows the influence of high sealed and built-up surfaces. Because of all the rainwater coming to this, the soil only 15% is able to infiltrate in the soil, whereas more than half of the rainwater is immediately running off through the sewing systems and the paved surface. Whereas in a vegetated area, about half of the rainwater can infiltrate in the soil and 40% is transpired into the air, meaning quite some humidity for all living organisms. The images on the right show the effect of green structures on the urban climate in the city of Leiden. The top one shows the heat map of perceived temperature and the bottom one shows the green areas within the public space. We see a concentration of orange and red in the city center, representing a high measured perceived temperature. Whereas there are dense vegetated areas, illustrated in dark green on the bottom image, the measured perceived temperature is significantly lower. Also at the housing level, the shade of a tree can already yield high temperature differences. If you look up at the image on the top left side, you see for instance that there is almost 20 degrees differences between the shade of the attic in the shade and the tree and the attic part which are in the full sun. This also applies to vegetated roofs and even for the vegetated space in between the stones of the pavement. They show a much lower temperature than in the middle of the brick, even up to 15 degrees Celsius in a couple of centimeters. Urban plant life also has consequences for the other. For instance, indigenous trees have a high level of insect life on a micro scale and fungi compared to exotic trees. Our indigenous trees also have a large distribution area, which means that they also have a large ecological envelope, and they can withstand quite some global climatic change. That means that we do not have to go to exotic trees to be so-called climate adaptive. Most of our indigenous trees have enough potential flexibility and phenotypic plasticity. Trees are important for the carbon cycle, and often it is called that the carbon is fixated in trees. That is in a way true, because growing trees fixate carbon. But when the tree dies, this carbon is coming back into the air again. What is important to know is that carbon is fixated much more in the soil than in the tree itself. 3/4 of the fixated carbon is in the soil and not in the tree itself. And if the soil is not manipulated too much, this carbon stays in the soil. So the sink of carbon is the soil and not the tree.